All right, section 2.2. Today we are taking a look at the other four trig function graphs. They're not as detailed, and now that we have created the sines and the cosines, they will help us significantly in creating secants and cosecants. But first we're looking at tangents and cotangents. So the tangents and the cotangents have some properties. These are much like the properties we saw listed when we did the others last time. So our domain is negative infinity to infinity, except for n pi over 2, where n is odd. We'll talk about what happens there in a little bit. The range, that's the y values, are from negative infinity to infinity. It is an odd function, which we've looked at before. The period is different. Period for sine and cosine was 2 pi. Period for tangent and cotangent is actually pi. It's going to have x-intercepts at every whole pi values, right? N pi just means all of my whole pi's, and the negatives as well. So like negative pi and negative 2 pi, those two. It's going to have a y-intercept at 0, 0. And then remember back above, it said that the domain is except n pi over 2, where n is odd. The reason that doesn't actually happen in the domain is because we have vertical asymptotes there. So that's number 6. This one should say 7. Oh, there's something missing. What's missing? Do I have 2 of something else? 2 ones. Formatting things going on. Okay, well, I'll fix them on my screen later. They're okay on your notes though, right? Wonderful. Okay, so the last thing is that the branches increase. So let me draw for you what this looks like so that you can see kind of the image that's being described. It's got an x-intercept, y-intercept at the origin. It has asymptotes at every pi over 2 value. I'll just draw one cycle first, or one period first. And the branches increase. They look like this. So this branch is happening at pi over 2. This one's happening at negative pi over 2. And at every whole pi value, we have another x-intercept. So that one's at 0, and this one's at pi. And then we have another one over here at 2 pi. And in between them is going to be another asymptote like this. And the branches repeat. And it keeps going to the left and to the right forever. Okay. The graphs look a little bit like an x cubed graph, if that's one that you're familiar with. But they're bounded, right? They're trapped in between these asymptotes. So every whole pi value, we have an intercept. Every half pi value, we have an asymptote. And this is coming from, I should have written this first. This is me going out of order a little bit. I was getting so excited about the graph. From the xy that we were doing before. So if we had done negative pi over 2 and looked at that, what we would have found from the unit circle is that this is an undefined value. The undefined value is creating the asymptote there. And then if we had come over here to 0, in fact, let me put negative pi over 4 in here as well. If we had done negative pi over 4, we'd have gotten a negative 1. So there is a value like right here. And then there's one right here giving me the negative 1 and the positive 1. In between I had 0. That was the 0. Pi over 4, I had 1. And if I go to pi over 2, I get another undefined value. And this repeats. So it goes undefined, negative 1, 0, 1 undefined. And that's the branches that you see happening here. So you have asymptote. And you've got the negative 1 value, and then you've got the 0, the x-intercept, and then it goes up and it increases from there. So this is what our tangent graph looks like. Now cotangent is going to look very similar. It's going to have these repeating asymptotes going on. That kind of should make sense. These are reciprocals of each other, so they should have some sort of a feel of them being similar. However, all of the places where we would have a 0 here for tangent are going to give us an undefined for cotangent. And all of the places that are undefined for tangent are going to give us 0s for cotangent. So what's going to happen is that my graph is going to look like it's shifted, kind of like it looked when we did sines and cosines. They shifted from one another. Do you remember that? You can also think about the fact that when we talked about co-functions back in chapter 1, sine and cosine are co-functions. They're a shift of pi over 2. Tangent and cotangent are co-functions. There's a shift of pi over 2. Okay? So the other graph that we're doing here, let me just write the xy's down first this time. If I want to start with, and I'm going to start with 0. I want to get an undefined value if I put in 0. So if I actually go back to my unit circle and I look at pi over 4, at pi over 4, I get a value of 1 for tangent and for cotangent. Okay, it's square root 2 over 2, square root 2 over 2. When we divide them, we get 1. And then if I go to pi over 2, I actually end up with a value of 0. And that makes sense. That's what I mentioned over here, right? That this pi over 2 being undefined, it came from the value of 1 over 0. And if I flip it and do 0 over 1 for the reciprocal, I get 0. So you can kind of think in your mind like undefined and 0 are reciprocals of one another. They are in the sense of the values that they achieve for us. And then we'll do the last two here. So if I actually go to 3 pi over 4, I'm going to get a negative 1. And if I go 1 further to pi, I'll be back at an undefined value. So let's go through the details here. Now this one, mine has, there are 2 6s on this one, aren't there? Look at that. My numbering of my computer it decided it was going to do some fun stuff. That sounds awesome. PowerPoint for you. Okay, anyway. The domain, again, is all of everything, right? Negative infinity to infinity, except for the locations where there's intercepts. And this time they happen wherever there is a whole pi value, so the n pi's. The range is negative infinity to infinity, and it is an odd function. Okay, so all those things are the same as before. Period as well, same as for tangent, it's pi. Now my x-intercepts are occurring at the same places that in tangent's world, those were the asymptotes. So it's the half pi values. So n pi over 2, or all the half pi's, is where I'm going to have my x-intercepts. There are no y-intercepts because we actually have an asymptote on the y-axis. There's going to be vertical asymptotes at every whole pi values now instead of the half pi values. And this one's different. The branches are decreasing. And you can see that as we take a look at these values, right? It goes from 1 to 0 to negative 1, where my other one went from negative 1 to 0 to 1. So they're going to change on that. So I'm going to draw this in yellow because otherwise I can't see my asymptote along the y-axis. I think that'll work, okay? So at every whole pi value, I have an asymptote. So I'll draw out 3 periods for now, like this. And at every half pi value in between, I have my x-intercept. So my x-intercepts are now at pi over 2. I need that to be a smaller font. Okay. This one's at pi over 2, at 3 pi over 2. It'll be at negative pi over 2, okay? And then the asymptotes are happening at whole pi values. So this is pi and 2 pi. Over here we have negative pi. Clearly that's 0. But now the branches decrease. So the branches look something like this. So it kind of looks like, and it actually really is, tangent turned upside down and shifted. And if you turn my tangent sign upside down, you get decreasing branches, and then you shift it over just a little bit, pi over 2, and you'll have this value. So just like with sine and cosine, how do we go about graphing these? Well, we have sort of a list of guidelines on how to do it. They're very detailed looking. They're really not that difficult to work through, but there are some details that we want to make sure we don't miss along the way. So having an idea of what ones we're working through, what kind of steps we're working through is a good plan. So some guidelines for graphing tangent and cotangent functions. So when we're dealing with either tangent or cotangent, where the b is greater than 0, that's what the should say b. Oh, that's why. Does yours have it? Yeah, it's a typo. There's a b right here. It's on the notes, but it didn't show up in my graph here. I've got some problems with my screen today. I'm so sorry. So if you have tangent, y equals a tangent bx, or y equals a cotangent bx, where b is greater than 0, you can determine the period by dividing it by b. So pi was our original period that we'd listed on the other 2 slides. But if there's a coefficient inside with x, we would divide it by that value. That's just what we did when we did sines and cosines. That's nothing new. We took the original period. In this case of sines and cosines, it was 2 pi, and we divided it by b. Here we're taking the original period pi, and we're dividing it by b. For tangent, because of the way asymptotes show up, we've got a shift that's different than for cotangent. So for tangent, we're actually solving negative pi over 2 to pi over 2. And the reason this is happening is because for tangent, these are the locations of those sort of first asymptotes. So these are the asymptotes that you're looking at here. And the same is true for cotangent. It's just that the cotangent asymptotes are at 0 and pi. So we're taking the most centralized asymptotes and we're setting up what looks kind of like what we did with phase shifts back in section 2.1. We're looking at them as a triple inequality, and we will solve that for x. What that finds for us is the location of the asymptotes in one of those periods. And then we can generalize it for a second one if asked to do so. So number 2 is we sketch the asymptotes that we found in step 1. Step 3 is to divide the interval in half. That middle value, that half location, is the x-intercept. And then we're going to use the x-intercept and the asymptotes to sketch the appropriate curve. They look like those branches. And then we draw the graph over additional periods if needed. And it does seem that, generally speaking, the default that your book likes to do is 2 periods for these. Just FYI. Sines and cosines, they tended to want to do just 1 period. Certainly could ask you for more, but that was sort of the default. Here, the default's going to be 2 periods. Okay, so let's take a look at a graph for these and kind of process through how it works. So we've got y equals the cotangent of 3x. Oh, I should mention, I didn't actually say it, but let me mention it out loud. Notice it didn't say anything about what the a is here, right? It just didn't talk about it at all. A, when we were working with sines and cosines, was amplitude, and it had to do with the peaks and the valleys, right? We don't have peaks and valleys on cotangent graphs, right? They start at the bottom, they go to the top. They start at the top, they go to the bottom. They're completely increasing, completely decreasing. So what in the world does the A do? Well, it gives it a stretch. And so it either stretches it and makes it look like taller and skinnier. It's still trapped between the 2 asymptotes. It's just taller and skinnier. Or it sort of compresses it down and it like compacts it a little bit, so kind of like Play-Doh, right? And it pushes it so that it looks a little bit more closely connected to the x-axis when it gets squished. But the rest of the graphs generally stay the same, and we don't have to effectively draw anything differently depending on what the A value is at the beginning. There's no difference in the way we draw our sketch, because we really are sketching. We're not really trying to do an accurate, perfect drawing, okay? So the A doesn't affect the graph. All right, so we're going to graph the function over a 2-period interval, and our graph is supposed to be for y equals the cotangent of 3x. It does say negative on my paper too. I went in and I added it and I forgot to change my slide. Thank you. Y equals negative cotangent 3x. Perfect. I put this in here. I changed it to a negative after I originally did it because I wanted you to see what happens with negatives. What does a negative do when we did sines and cosines? It reflected it, right? This is going to reflect this as well. So we're going to have a reflection here. And Carson's right, it's over the x-axis. So I'm going to sort of make a note of that. That's not part of my steps of things, but there's a negative that I got to deal with and do something with, so we need to be aware of that. The other part of it then is this 3 pi or this 3x business. So that's going to affect my period. So my period is now going to be pi over 3 because it's supposed to be pi over whatever the value is that's multiplied by x. This is the period that I have. Okay? So then, how do I find these asymptotes? Well, for cotangent, it's originally set up to be between 0 and pi, right? So I've got this value now, 3x, between 0 and pi. And I divide everything by 3. Still have 0 on the left, and there I get that pi over 3 on the right. What that does is that gives me a place in which to start my graph when I'm sketching. So let's get the right tools up here. So I need my graph to start at 0. So I can draw an asymptote in at 0. Can you see that that's dotted over? That's not too bad, but I always like to put a little bit to the side if I can. Let me do it this way. shift it so that you can see it showing up a little bit better. It's there. It's supposed to be on top of it, but I can't draw it on top and really see visible, very visible. There's going to be 2 more asymptotes because I have to draw 2 periods, right? Like this is what has to be drawn. I just need to make sure I label correctly where those asymptotes are occurring. So the first one's happening at 0, and the second one is happening at pi over 3 because this interval tells me so. So this is pi over 3. Okay, so the interval that I've set up in that inequality give me 2 of my asymptotes. But I need to find a third one. How do I find this third asymptote? I add pi over 3. Yeah, whatever the period is, this is why we found the period actually, is that I need to add that to whatever's here. So what happens when I add pi over 3 and pi over 3? You get 2 pi over 3. So the next one is at 2 pi over 3. It's a little messier when we do tangents. We'll do a tangent graph here next, but it's a little messier for those. But cotangents are really nice because they start at 0. So we're always going to get the 0 showing up, and then we have one more, and it's going to be the same value as the pi. Now, typically speaking, let me actually do this first. Split the interval in half, make my x-intercepts. Those are part of the directions, so all that's good. Typically speaking, we'll label in a second. The cotangent graph should be what? Increasing or decreasing? Should be decreasing. But we got the negative in front, so Isaiah's right. This reflection over here tells me it's going to now be an increasing graph. It's going to look like tangent. All right, so cotangent is decreasing. This is typically, right? But when we have negative cotangent, it's going to be increasing. It's just going to flip it upside down, so I'm going to have an increasing graph. We'll still need to label what those x-intercepts are, which we will. But our graph is going to look kind of like the tangent graph now, right? Okay, so what is halfway in between 0 and pi over 3? It is pi over 6. Okay, how do you find that? Well, generally, you add the 2 numbers together and divide by 2. It's very nice because one of them is 0, but 0 plus pi over 3, and you divide by 2, this gives you pi over 6. I need to find one more, though. I need to find this one. I need to find halfway between pi over 3 and 2 pi over 3. So if I take pi over 3 plus 2 pi over 3, and I divide by 2. What's pi over 3 plus 2 pi over 3? It's pi, right? Right, you got that 3 pi over 3, so pi, and then pi divided by 2 would be pi over 2. So kind of unexpected maybe that showed up that way. It is pi halves. Okay, so this is the fraction stuff that I mentioned when we were talking about the test. If fractions are bugging you, come chat with me and we'll do some quick tricks and remembrances of how to deal with fractions to make sure that those don't trip you up. Okay, the other one is tangent that we're going to look at right now. So tangent, so y equals 1/2 tangent 4x. What did I tell you about this 1/2 business in front?
It's a stretch.
It's going to be a stretch or a shrink, right? But what's it going to do when we graph? It's not going to affect our graph at all in terms of what we sketch. Okay, so this won't affect what we sketch. There we go. Won't affect our sketch. So with it being a 1/2, it's actually a shrink. What it's actually going to do, if you graphed this with the 1/2 and without the 1/2 on your calculator, it's just going to compact it a little bit more towards the x-axis. Fractions are going to compact. Bigger numbers than 1 are going to stretch. So, but they don't affect our graphs for what we're sketching. We're going to look next at the period then. So the period is what? Yep, pi over 4. It's pi over whatever the value is that's located next to x. And then we're supposed to be going between negative pi over 2 and pi over 2. And then our 4x is in between. So what are we going to do to solve this in the middle to have just x? Yeah, you're going to divide by 4. Or similarly, you could say you're multiplying by 1/4. Either way. This is going to give me negative pi over 8 to pi over 8. Right? Pi fourths divided by 2 is pi eighths. So when I come over here to my sketch my graph needs to start, and this one is still very balanced, right? It's equally distributed around the y-axis. So it's going to balance it on either side, like this. And at about that distance away, I need another one because I'm supposed to draw 2 periods. So I'm going to sort of draw my sketch in, and then I need to figure out what the labels are. 2 of the labels we get from the work we've already done. Right? We don't get them for free. It's just we already did the work. We have negative pi over 8 and pi over 8. So that's this one and this one. How are we going to find this next one?
Just add pi over 8.
Close. We're going to add pi over 4. So Olivia Grace, why are we adding pi over 4? Where'd you get that?
The period.
It's the period. So we have to go back up to the period to figure out how much we're adding. Okay? So to get from here to here, we're going to add the period. In our case, pi over 8 plus pi over 4 is what we have. And if we get common denominators and so forth, this will be 2 pi over 8. So pi over 8 and 2 pi over 8 would give me 3 pi over 8. So this last one that we haven't labeled, that's drawn in, is 3 pi over 8. One of the intercepts is easy. It's right here, right? It's actually on the origin. That's great. The other one's right here, but I need to label it. What value is that? What is it? It is 2 pi over 8, yeah. So let me jot that down. We're not going to write 2 pi over 8, but you're correct. It's 2 pi over 8. How can that be written? Pi over 4, yeah. So Carson, how'd you get pi over 8, or 2 pi over 8?
Because 2 pi over 8 is between pi over 8 and 3 pi over 8?
Yeah, that's a really good way to look at this, right? Halfway between 2 and 3 in terms of the pi over 8s would be, between 1 and 3 would be 2, right? You could also take a look at that each of these are adding pi over 8 to get to the next one, right? To go from asymptote to intercept to asymptote. They're all adding pi over 8 each time. So yes, this is 2 pi over 8, which is otherwise known as pi over 4. And we've got a tangent graph. Is tangent increasing or decreasing? It's increasing. So my branches will increase and look something like this. Okay, looks like I have one more. I didn't remember I had one more, but I do. What's different about this one than the last two? It's got a phase shift, that's right. So there's addition and subtraction inside of there, and you'll notice I didn't write a whole nother set of directions for what to do about this, because we don't really need a whole nother set of directions. We already talked about how we would go about finding period. It'll be the same, even if there's a phase shift. And we talked about how we find those asymptotes. And it'll be the same because it's actually including the details for a phase shift within them. So let's take a look. When we're finding the period of this, the period will be pi over the number multiplied by x. So what number is multiplied by x? 1. It's just 1. So my period is still pi here, right? Okay, so that addition and subtraction business doesn't affect my period. However, when I'm looking at sort of a phase shift, it's the same as what we were doing when we were setting up the intervals between right here. We're going to set it up just like this. So my tangent is from negative pi halves to pi halves. So this is negative pi over 2 to pi over 2. And what goes in between is still what's inside of tangent. It's just that at this time there's addition inside there too. So we have, or subtraction, I guess, x minus pi over 4 inside. Okay, so what are we going to do, Isaiah? You just said it.
Just add pi over 4.
Yeah, we're going to add pi over 4 to all 3 sides. Okay, so in the middle, of course, they cancel. What happens if I have negative pi over 2 and positive pi over 4? We get negative pi over 4. And I know that some of you have looked at these and just ignored the pi's, which you can do as you're thinking about this, right? This is negative 1/2 and positive 1/4. You've added them together and then put the pi back on afterwards. That's totally fine. That is what we're doing. And your calculator can also support doing that with most, I would say most, with some of our fractions anyway, it would be able to for here. This is negative pi over 4. In the middle, I have an x. And then on the right, I have pi over 2 plus pi over 4. So what is 1/2 plus 1/4? 3/4. This is 3 pi over 4. Now, that's not very friendly. It isn't. Because it's no longer equally distributed around the origin. That's not very nice. It's going to make our graph a little bit messier looking, but we can handle it. So we're going to go from negative pi over 4 all the way to 3 pi over 4. So it's going to look unbalanced. I didn't mean pi over 4 there. Sorry, 3. Oh, I just missed my 3. That's what I'm missing. 3 pi over 4. How do I find what's halfway in between these guys? Because that's my x-intercept. Just what? Did you have an idea? Sorry, say loud. Yeah, so what we were doing before is exactly what we'll do again. We're going to add them together and divide by 2. It's just that they don't balance and divide and look very nice, but they'll still work the same way. So if I add negative pi over 4 plus 3 pi over 4, and divide by 2. So what is negative pi over 4 plus 3 pi over 4? Let's start with the top. So let's look. Okay, it would be 2. It would be 2 pi over 4 first, right? Okay. And then we're going to divide by 2. So what is 2 pi over 4 divided by 2? It would be pi over 4. So feel free to adjust this on top to actually, I'm sorry, I said 4 and I wrote 2. To adjust this to say pi over 2, which is what the gentleman up here at the front were saying, which is fine. But then when we have pi over 2 divided by another 2, we're still going to get pi over 4. It is at pi over 4 that it's crossing. Oh, goodness. I'm going to shift that over here a little bit and put pi over 4. I need another set of branches because it said, or another asymptote for the additional branch because it wants me to do 2 periods. So what is this asymptote's value going to be over here? We need to add a pi. So to get from here to here, I need to add pi. So what is 3 pi over 4 plus pi? 7 pi over 4. Very good. Now here's the deal. You could add these together and divide by 2 just like we did down here again if you wished to find the location in the middle. There's nothing wrong with that at all. But just like it is a pi value to add to get from asymptote to asymptote, it's also a pi value to add to get from intercept to intercept. So you could add pi to get there instead. So if that just threw you for a loop, just add them together, divide by 2, that's fine. But it's also adding pi to get from the intercept at pi over 4 to the next intercept, because that's what a period does. Every piece of this is cyclic. It just is always going to show up again and again at an interval of pi. So if I add pi to this, or if I add the 2 values together and divide by 2, what's my next x-intercept? Yep, it's 5 pi over 4. All right, is my graph increasing or is it decreasing? It is, we've got tangent. It is increasing, right? Okay, so the graph looks like this. All right, we're going to pause there for today.